Hey learner, I hope you all are doing well. So today we'll see the assignment number 3, that is title implementation of sliding window protocol, that is go back n method and selective repeat method. So objective of this method is that to demonstrate go back n method and selective repeat modes of sliding window protocol in peer-to-peer mode. So what is the problem statement? Write a program to simulate go back n and selective repeat mode of sliding window protocol in peer-to-peer mode and demonstrate the packets captured traces using Wireshark packet analyzer tool for peer-to-peer mode. This is the outcome of our assignment after completion. Demonstrate go back n and selective repeat mode and also capture packets using Wireshark packet analyzer tool for peer-to-peer mode. So which are the tools required to implement that assignment? Hardware we required machine or computer. Software we required JDK compiler and Wireshark packet analyzer tool. The basic idea of sliding window protocol is that both the sender and receiver keep a window of acknowledgement. The sender keeps the value of expected acknowledgement while the receiver keeps the value of expected receiving frame. So in this way the sending and receiving keep the acknowledgement in the form of three-way handshake mechanism. There are two different ways to develop for flow control, namely stop and wait protocol and sliding window protocol. Sliding window algorithm used by TCP, it permits multiple data packets to be in simultaneous transit, making more efficient use of network bandwidth. We will see the sliding window protocol. In this, the header frame, if the header of the frame allows k bits, the sequence number range from 0 to 2k minus 1. The sender maintain a list of sequence numbers that it is allowed to send by using the sender window. The size of the sender window is at the most 2k minus 1. The sender is provided with a buffer equal to the window size. Receiver also maintain a window size that is 2k minus 1. The receiver acknowledges the frame by sending an acknowledgement frame that includes sequence number of the next frame expected. This is also explicitly announces that it is prepared to receive the next n frames beginning with the whatever number of specified. This scheme can be used to acknowledge multiple frames. It could receive the frame number 2, 3, 4, but acknowledge may be arrived or lost. So we will see the actual scenario here. This is the sliding window protocol. So here send the packet, receive the packet number 1, send the packet number 2, receive the packet number 2, send the packet number 3, then whatever receive the packet number 3, send the acknowledgement 1, received acknowledgement 2 for packet number 2, acknowledgement number 3 for packet number 3. This is the simple way. Packet number 1 sent and receive the acknowledgement number 1 for that. Packet number 2 sent and receive the acknowledgement number 2 for that. Packet number 3 sent and receive the acknowledgement number 3 for that. In this way, the sliding window protocol will work. Second method is go back n ARQ method. So in go back n ARQ method, The sequence number are modulo 1 factorial, where m is the size of the sequence number fields in the bits. Suppose sender sending the data 0, 1, 2, 3, 4. Then receiver receives the data and send the acknowledgement of those frames which are damaged or not received successfully to the sender. Here the NAK2 negative acknowledgement 2, it means that data number 2 is not received by the receiver and it is a damage or loss in between the transmission. So once the sender receives the negative acknowledgement number 2, then from frame number 2 remaining all the data frame will be retransmitted or resent. That is data number 2, data number 3 and data number 4 will be resent again. So that is called as go back NARQ. Means whatever the number of whatever the sequence number damage or loss onwards, all the data frame need to retransmit or resend. That is called as go back NARQ method. Then another method is selective repeat ARQ method. In that method, so only the lost or damaged frame will be retransmitted. Here sender sending the data 0, data frame 2, data frame 3, data frame 4. 4 frames are sent by the sender. Receiver receives all these frames, but the frame number 2 is damaged or loss in between the transmission, and sender receives the negative acknowledgement for a frame number or data number 2. Then sender receives that negative acknowledgement 2 and resend only data frame 2 only. That is called as selective repeat. Means only those frames are damaged or lost, only that frame will need to resend or transmit again by the sender side. That is called as selective repeat. So these are the, so finally I conclude that hence we have implemented of sliding window protocol for go back N method and selective repeat methods. So these are the review questions for our today's topic. What are the functions of data link here? Then explain in detail sliding window protocol. Then explain selective repeat protocol and go back NARQ protocol. Then compare sliding window, selective repeat and go back NARQ protocol. Thank you very much.